going to be talking about performing operations with complex numbers, keeping in mind that when we say the word operations, we're talking about adding, subtracting, multiplying, dividing. Okay. Also, taking the square root and raising a number to the second power, squaring numbers. So, onward and upward. The most important thing we have to understand here is that not all quadratic equations have real number solutions. Sometimes there are funny looking things. So let's focus on the last thing that we were working on, solving quadratic equations using square roots. Well, now enters our imaginary unit. And what is it? It's exactly what it says. It's imaginary. We're going to express it with the lowercase letter I. And I is defined as the square root of -1. So, just as it follows, say that since 3 is the square root of 9, then it would follow that 3 squared equals 9. Well, then it follows over here that if I is the square root of -1, then what do you think? I squared must be equal to -1. That's all you really got to keep in mind. So we could put these two things together and we could do like a little combo. Well, what's the square root of -9? Okay, well the square root of -9 could be broken down into two pieces. -1 times 9. Square root of -1 is I, and the square root of 9 is 3. And we put the imaginary unit after the real unit. So, 3i. So let's immediately put this new knowledge to use. We have a problem here to solve, so what are we going to do? First thing we're going to do, solve using square roots. So subtract 11 from both sides. I get 2x squared is equal to -48. Divide by 2. Divide by 2. X squared is equal to -24. Take the square root, and we got a problem. Got the square root of -24. Let's digress for a second. Over to the sidebar here. These two terms here, I just want to make sure that we know these guys are not the same. The first one is the opposite of the square root of 24, and this is the square root of -24. The first one would be broken down into negative 2 radical 6, right? Because 4 times 6 is 24. And the other one would be, well, this is right above for a second. This is -1 times 4 times 6. So that would be 2i radical 6. So down here it follows in the same road, right? So we got this -1 times 4 times 6. This is why we have bringing along our solving square root knowledge. So x is equal to, the 4 becomes a 2 on the outside, the -1 becomes a I on the outside, it's kind of a funny looking I, and the 6 stays in here, goes along for the ride. And don't forget, I almost did, plus or minus all that, there's two different solutions there, a positive and a negative. Okay. Just before we walk away from this problem, I just want to sort of demonstrate what's happening here. If you take this original piece, add the 37 to both sides and set it equal to 0. Now take that 0 and turn it into f of x. All right? Because normally we would start with it in standard form, although there's no linear term here, right? You would have had 2x squared plus 0x plus 48 equals f of x, right? Working backwards, now, upwards, we could replace f of x with 0 and then solve by factoring or solve using square roots to find the zeros. Well, when you look at this in standard form, what is this positive 48? That's our y-intercept. That's a positive. Which way does this thing open? Up. What's this never going to do? Cross over the x-axis. So what doesn't it have any? It doesn't have any zeros. What are we looking for over here when we solve? We're looking for the zeros. You're looking for something that doesn't exist, so you're going to get answers that have imaginary values. Ding, ding, ding. Let's try a couple more. So we got x squared equals -13. Square root, x equals plus or minus I radical 13. Done. Next, x squared plus 11 equals 3. Subtract 11 from both sides. X squared equals -8. take the square root of both sides, and you get x equals plus or minus 2I radical 2, right? Because that square root of 8, negative 8 is negative 1 times 4 times 2, right? And then out comes the 2, out comes the I, and stays the 2. Boom. Done. 3x squared minus 7, so what are we going to do? Add the 7, add the 7, you get 3x squared equals 31 minus 7 is 24, divided by 3, divided by 3, x squared equals, whoops, that was a negative 24, negative 8, take the square root, and we've already taken the square root of negative 8, so it's still know the same program here. This is still plus or minus 2I radical 2. I stole it from the taking the square root of negative 8 there. Okay? I know these are labeled 2, 4, and 6. Just label them like that in your notes. You answer these, and you bring these answers into class. Next, what happens if we need to add complex numbers? Well, if you look to the right side over here, this is very similar to over on the left side. So we'll sort of divide them up and work them in parallel. Well, what could I do here? I would add the 8 and the 5, right? Okay. When I see the parentheses, I think distribution. There's technically 1s out in the front here. And when you distribute the 1 through, you're not going to have anything other than just 8 minus x plus 5 plus 4x. All right, so, whoops. So the 8 and the 5 are like terms. That's 13. And a negative x plus the positive 4x is plus 3x. So I sort of look at the imaginary unit in the sort of same way, like terms. So we got 8 plus 5 is 13, and the negative I plus 4I is plus 3I. That's it. It's that simple. Again, looking at parentheses, seeing these 1s, I distribute the positive 1, I get 7 minus 6I. No change. I distribute the negative 6I, I get a change in sign to both items. Now, I have this little jingle, and I used to say is draw the line, change the signs, right? So now this one's negative and this one's positive, but it is distribution. Now I'll combine like terms. 7 minus 3 is 4. Negative 6I plus 6I cancels out. I'm left with just 4 as a final answer. Let's try another. Okay, so I have the 10 minus the parentheses, 6 plus 7I plus 4I. That's a negative 1, so that's 10 minus 6 minus 7I plus 4I. I don't distribute that 1 out to that 4. It's not inside the parentheses. I'm just distributing the negative to the parentheses, changing those signs. 10 minus 6 is 4. Negative 7I plus 4I is minus 3I. Final answer, right? That's that. Again, here's 3 more problems for you to finish for your homework and bring to class. And last but not least, of course, if we're going to do addition and subtraction, we definitely are going to have to do multiplication, perform multiplication. So let's multiply. And what are we going to do here? We have a monomial times a binomial, so we're going to distribute. Negative 4i times 4i times a negative 6 is going to be a negative 4 times 6 is, 24i. And then 4i times positive I is positive 4i times I is I squared. But then don't forget, at the very beginning of the video, we said that I squared was equal to negative 1. So that's negative 24i plus 4 times negative 1, which is negative 24i minus 4. We like to write the real number first, so we're just going to write it negative 4 minus 24i for a final answer. Okay? Let's try a couple more of these. The only difference for this one is it's a binomial times a binomial, so we're going to FOIL. First, negative 36. Outers is going to be positive 63i. Inner, negative 2i times negative 4 is going to be positive 8i. And then our last, negative 2i times positive 7i is negative 14i squared. But don't forget that the I squared is the same as negative 1. So that's going to be negative 36 plus 63i plus 8i plus 14, because you got negative 14 times. Right? It was times I squared, so it's times negative 1. So that sign basically is just every time you see I squared, it just basically represents a sign change. All right, now let's just combine our like terms. So we got the negative 36 plus 14 gives us a negative 22. Then you got the positive 63 plus 8i is going to be a positive 71i. Our real number is in the front. Our complex is second, so there's our final answer. Final expression, I should say. And for our last piece here, again, we only like real numbers in the denominator, and since I is imaginary, we're going to have to, that's right, rationalize the denominator. It's very simple. We're going to go with our conjugate, but when it's imaginary, we call it the complex conjugate because imaginary numbers are also referred to as complex numbers. So we'll get the binomial times the binomial on the top and on the bottom. So this is going to be work, but it's not going to be incredibly difficult. Press pause, work this one out on your own, then match yours up with mine. So I got negative 13 plus 33i over 17. If you didn't, let's just take a quick look up here. 7 times 1 is 7, then you got the plus 28i, plus 5i, and the plus 20i squared. I squared is negative 1, so that makes the plus 20 a minus 20, and 7 and negative 20 is negative 13. The 28 and 5 gives us a 33i on the top. On the bottom, you're going to get 1, and just like we've had in the other rationalizing denominators, it's really just the first and the last terms that are going to be remaining because you're going to get the plus 4i and minus 4i right here. Those are always going to cancel out. Again, that's the magic of rationalizing the denominator. This should happen. And we get the minus 16i squared, which becomes a plus 16, and 16 plus 1 is 17. That's it. One more and we're done. 5 over 1 plus I, so we're going to multiply by 1 minus I on both top and bottom. Okay, on the bottom I'm going to FOIL, on the top I'm going to distribute, so that's going to give me 5 minus 5i on the top over 1 minus I plus I minus I squared, which is going to cancel out to be plus 1. So that's going to give me 5 minus 5i on the top all over 2. And since I'm looking at all three of these numbers, since they all don't cancel out, there's no way to reduce this. Say, for instance, this was 6 minus 5i all over 2. Don't try to cancel out this 6 and 2 and make that a 3 and a 1. No. All three terms got to play nicely together. And again, some funny numbered problems, but 11, 12, and 14, there you go. Last three should be done for homework. See you next class.